So we're asked to approximate this integral using the fact that sine of t is approximately equal to this when you start splitting up the terms of the Taylor series. So that means that sine, look, we don't have sine t, we have sine pi of t. So we can rewrite a bit the above approximation. So this, I'm just sticking a pi next to t. And so just watch out, that's pi t to the third. You got to put the whole thing to the third power. And I think you get the idea. Pi t to the all to the fifth power for 120 minus that last term. Okay, so that's not exactly what sine of pi t is, but that's a rough approximation. So we can rewrite this integral as the integral from 0 to 1. In the numerator, I'm going to replace it with pi t, and we should use, we should say that this is approximately equal. Okay, but in the numerator, I'm going to put pi of t minus pi t all to the third power over 6 plus pi t to the fifth power all over 120. Okay, so that's what the numerator is. The denominator is still just a pi t, but that's actually going to make things easy for us because now, look, everything has a pi t involved. Pi t divided by pi t, that's 1. Pi t divided by pi t makes 1. Now pi t to the third divided by 6, that's all being divided by pi t, so that brings it down a power. So now this is pi times t to the second over 6. And then this is pi times t to the fourth now over 120, and I'll add that last term in. We had, this is going to be pi t to the seventh, but since it's being divided by pi t, now it's going to be pi t to the 6 over 5040. I don't think this question gets randomized, so I don't want to give away the answer here, but you're just breaking it up into separate integrals now. The integral from 0 to 1 of 1 minus the, now you look, this is a constant and divide by 6, so you can just factor out pi squared over 6, then integrate from 0 to 1 t squared dt. And then just don't forget your signs are alternating. Oh, I forgot that. Okay, that's a problem. Minus plus, practice what you preach, huh? Minus. Because as you probably know by now, with the Taylor series for sine and cosine, you're going to have alternating signs. So that should actually be a minus there. So that was incorrect earlier. Yeah, but I gotta leave this part. Just a little bit of calculus to finish this out. Those are easy integrals too because it's from 0 to 1. I guess for completion, I'll write the last part. This is pi to the 6 for 5040, and you're integrating that from 0 to 1 of t to the 6 with respect to t.